So your startup is growing fast, users are coming in, sales are ticking up. But behind the scenes, releases are slow, your team is buried under bugs, infrastructure costs keep creeping up, and every time you fix one problem, three more pop up. If that sounds familiar, you're not alone. Today, I'm going to show you how you can go from technical chaos to clarity without burning hundreds of thousands of dollars in the process. When I step into a scaling startup as a fractional CTO, I usually see the same five red flags. One, release cycles slow down. What took hours now takes weeks. When a startup first launches, deployments are fast because the code base is small and dependencies are a few. As features pile up, the build pipeline becomes heavier, test suites take longer, and manual QA steps actually start creeping in. Small changes can now require multiple sign offs or affect unrelated parts of the system due to poor modularization. This creates a compounding effect where engineers become hesitant to deploy often, leading to large, risky releases instead of quick incremental ones. The slowdown directly impacts your ability to respond to market needs. Two, infrastructure bills are climbing, but no one can explain why. This usually happens when cloud resources are provisioned ad hoc without monitoring or lifecycle management. Services may be running on low utilization but remain on expensive instance types. Test environments or old workloads get left running indefinitely. Storage grows unchecked due to unarchived logs or unoptimized databases. Without proper tagging, cost optimization, it's impossible for you to know where all of this went. The lack of visibility makes it hard to fix, and the bills just keep climbing month over month. The third thing I see is most startups get into firefighting mode. When architecture, monitoring, and testing aren't robust, the team shifts into a kind of reactive mode. Bugs, outages in production consume the majority of engineering bandwidth. Root causes often trace back to brittle integrations, lack of automated testing. That's one of the most big ones, and infrastructure spikes. So this kind of erodes the developer morale, and the work just kind of comes to a halt. What's worse is urgent fixes are often patched quickly without fully resolving underlying issues, which means the same problems reappear just in another form. The fourth is feature backlog paralysis, the teams spending all their time on maintenance instead of growth. If most engineering capacity is devoted to fixing bugs, refactoring, or emergency performance tuning, new development stalls and almost comes to a crawl, actually. The backlog of planned features grows while competitors continue shipping improvements. This imbalance is usually caused by unchecked technical debt, areas of the code that are hard to change without breaking other parts of the system. Over time, the business feels the impact as customers see slower innovation and fewer reasons to stick around. The last one, and this is kind of a tricky one, but talent churn. Great engineers leave because they're frustrated. Top engineers thrive when they can build, solve interesting problems, and see their work ship quickly. In a chaotic environment where progress is slow, decisions are unclear, and most time is spent on repetitive firefighting, the frustration really builds. If leadership doesn't address the root causes, the best people in your company will leave for environments where they can have more impact. Every departure increases pressure on the rest of your team, creating a negative feedback loop that's expensive and slow to recover from. The worst part, founders often think this is just the cost of growing, but it's not true. It's the cost of growing without a plan. So here's the framework I use with my clients to scale without overspending. Four stages, very simple. It's architecture, people, automation, and costs. So let's say architecture first. Before hiring more engineers or rebuilding from scratch, which a lot of engineers are tempted to do next, is your database schema wrong? Is it slowing things down? Are these services too tightly coupled if you're in microservices? Do you have a clear separation between core systems and experimental features? Are you using feature flags? If you're not, that's something that you should. Good scaling often starts with understanding how your system is structured and where the bottlenecks are. Many startups begin with monolithic architecture because it's fast. It's fast to build, it's fast to prototype, but the product grows and tightly coupled components make changes risky and time consuming. Oftentimes, this can also show up as tribal knowledge if it's not documented very well. A few sets of engineers really know one part of the system, while new ones that you're onboarding quite don't understand, and so they don't really help adding new features. Mapping out dependencies, identifying high traffic or high risk areas lets you decide whether to modularize, refactor, or really just isolate specific services or even modules within a service. This doesn't always mean a complete rewrite. Often, targeted changes like splitting a critical API path into its own service or introducing a caching layer can yield significant performance gains. The key is making architectural improvements that remove constraint without overcomplicating the system while still maintaining the frequency of release and not hampering business operations. At Terrascope, I resisted a full rewrite and instead isolated high traffic services into separate modules. This alone improved stability by nearly 40%. No new hires, no massive bills. The second step in the framework is people and their roles. So, scaling isn't just about code, it's about team structure. Avoiding hiring only generalists, for one, really helps. Assigning clear ownership, back end lead, front end lead, DevOps lead, really helps. Introduce a technical decision making framework so you're not debating every choice endlessly, and developers love to debate. Even the best architecture will struggle, though, if the team structure doesn't quite support it. In the early stages, generalists wearing multiple hats makes total sense. But as the complexity grows, role clarity becomes essential. Assigning clear ownership of major domains, backend, front end, DevOps, infrastructure, reduces decision bottlenecks and accountability gaps. It also helps avoid the everyone is responsible so no one is responsible situation. A lightweight decision making framework ensures that architectural and technical choices don't get stuck in endless debates while still giving the right people a say. This clarity frees up mental bandwidth and it speeds up execution. Now, when it comes to decision making, there are a few proven frameworks that keep decisions structured and outcomes consistent. For example, although this is not comprehensive, one is DACI or DACI, like to call it. It is driver, approver, contributor, informed. So think of this as assigning decision roles before you even start talking. One person drives the process, the other person gives a final yes or no, a few contribute input, and others are just kept in the loop. That way, everyone knows their lane. The second framework that I like is called Rapid, and this one I think sounds a little better than DACI. Rapid is recommend, agree, perform, input, and decide. This is useful when multiple teams are involved. One group recommends a path, the people who must agree weigh in, someone is assigned to actually do the work, and one person makes the final call. It stops the we thought you were deciding problem. Now, all of these frameworks really kind of depend on your context, how many engineers and team members you have in your company, and a whole other things. But these are just guidelines. The next one is the OODA loop, which is the observe, orient, decide, and act. So this is also about speed. You look at what's happening, figure out what it means for you, decide on the next move, and then act. Then you repeat quickly. It's especially useful for fast moving startup environments where waiting for the perfect information can cost you opportunities. The whole point of putting these frameworks in and bringing in these best practices is so that you can grow from where you are right now, which you've clearly found product market fit if you're watching this video, into the next phase. You want to grow revenue, you want to focus on customer acquisition, but you also need your tech stack that's been serving you so well to take you on to that next phase. And a rewrite is rarely a good option. Decision frameworks and the ability to kind of spot bottlenecks in your tech often come together to form a really nice pathway to take you to your next level of business operations. One principle worth understanding here is Conway's Law. I'm pretty sure you've heard of it. Organizations design systems that mirror their own communication structures. In practice, this means if your teams are siloed, your system architecture will end up siloed too, often unintentionally. If you want a modular, well integrated system, you need a team structure and communication flow that reflects that same design. These frameworks and principles make sure the right people are deciding the right things and that your team structure supports, not undermines, your technical architecture. All right. So the third kind of big aspect in what I do once I step in is really kind of enforcing automation and tooling. If your team is deploying manually, you're already behind. But you really have to use continuous integration, CI, so that you can catch problems quickly. Automated tests are a must at this stage in your company's journey. Automated tests should cover your core business logic. Monitoring should definitely alert you before customers feel the pain. So, when you see spikes in traffic, if you see too many database errors, these kinds of things should be automated, and your infrastructure should be alerting your engineering team. Even if you don't have a dedicated on call team, you should have some form of alerting. It may be as simple as a Slack message. The next is continuous delivery with certain type of deployment that I like. It's called the green blue deployment or the blue green deployment, depending on who you speak with. Rather than pushing code changes directly to live users, a CD pipeline or continuous deployment pipeline deploys them to an identical green environment first. Once the verified traffic is switched from blue environment to green, traffic then moves to the green environment. The third is IAC or infrastructure as code. The right tooling should include developer productivity improvements. Therefore, local should kind of mirror production so far as deployment is concerned. Instead of manually creating servers or cloud resources, you define your infrastructure in code using tools like Terraform or AWS CloudFormation. This means you can recreate entire environments with one command, and every environment, dev, staging, UAT, production, is consistent. It eliminates the it works on my machine problem and speeds up onboarding for new engineers. The fourth is cost control, and this is one of those big ones I've seen in growing startups. Is a growing cloud bill is not a badge of honor, honestly. Audit unused infrastructure monthly. You can use spot instances or reserved capacity where possible, and you really need to monitor cost per user, not just total spend. Cloud bills often have, if you're on AWS especially, they can balloon quickly if infrastructure is not actively managed. So, cost control starts with visibility by tagging your resources, allocating costs by environment, team, or even service so you know where the money is going. Here are some low hanging fruits that you can employ today, right now, if your AWS costs are ballooning. The first one is right sizing cloud instances. Many startups run production workloads on oversized virtual machines, just to be safe. Over time, these are forgotten and continue to rack up costs. The second is eliminating idle resources. It's common to have one of those old test environments, abandoned databases or unused load balancers running in the background. Those are very common. These are easy to miss because they don't really break anything, they just keep charging you. So, setting up a monthly audit to identify and remove idle resources often recovers fairly large chunks of money in wasted spend. For example, at Ringgit Pay, a simple cleanup of unused staging environments saved the company more than $1,000 a month. Which, when you annualize that, that's $12,000. That's huge. The third, certainly not the least, is optimizing storage and data retention. So, storage costs climb steadily, especially when you have logs, database backups, old data that isn't pruned, etc. Implementing lifecycle policies such as automatically moving logs older than 30 days to cheaper storage like Amazon S3 Glacier can dramatically reduce spend without losing important records. I've seen this bring down a client's storage bill by roughly 30% while still meeting compliance requirements. So, while all of this information is useful, I'd like to point to a real use case or a real case study that I take from my own experience with the client. A SaaS startup that I worked with had just closed a $5 million round. They were ready to scale, but the tech was not crumbling just yet, but it was going to because they saw an influx of customers and they were putting a whole bunch of money into customer acquisition. Instead of rebuilding everything, we did the same framework. We mapped bottlenecks in the infrastructure, introduced role based ownership, automated the deployment pipeline, and ran a cloud cost audit. Within about 6 months of me stepping in as their fractional CTO, release frequencies tripled, uptime hit like 99%, and their AWS bill dropped by roughly 20%. But the best part is they didn't hire a single extra engineer. So let me leave you with this. Scaling isn't about throwing money or people or both at the problem. It's about making smarter, more intentional technical decisions, the kind that save you cash, time, and headaches. If you're a founder in that phase right now, this is exactly what I do at Xwami. Step in as your scaling partner, fix what's breaking or what you think might break, and help you grow without burning cash. You can book a call using the link in the description below, and let's talk about how I can bring clarity to your startup.